Alright guys, we are getting ready to do a lab called Determining the Molar Mass of a Volatile Liquid. And if you remember back to what the term volatile means, it means it is going to readily turn into a gas, hence the reason we are doing it in the gas law chapter. So the gas we're actually going to be playing with is inside of a lighter, and your job is going to be determining what that gas actually is. So remember, molar mass is a property that is distinct for specific compounds. So we can determine the molar mass, and if I give you a list of a bunch of compounds with their molar masses, you can then determine which compound was in the lighter based off the molar mass you calculated. So we will be using the equation PV equals nRT. And you could also use the equation that has density in it. So if we remember that density equals mass divided by volume. So we can replace N, the number of moles, by mass divided by molar mass. So we're going to come in here and plug that in. Okay. Bring molar mass over to the other side. So we end up with molar mass times pressure times volume equals the mass of the sample times R times T. Remember, we then divide by volume, and that's going to give us molar mass times pressure equals density, because mass divided by volume, R and T. So you could do it that way as well. Either equation actually will work just fine. But basically the idea behind it is you will be collecting several pieces of information. First off, you will be collecting the pressure of the gas, which we'll talk about how we're going to do that in just a minute. You'll be collecting the volume of the gas, because you'll need it for density. You'll be collecting the temperature, and you'll be collecting the mass. And that way you can plug all this information into either the PV equals nRT, or the molar mass times pressure equals density of gas times RT. Again, either equation will allow you to do what you need to do. Okay, so from here, what you're going to do, let's talk about the actual procedure of the lab. You're going to have a plastic container, and that plastic container is going to have water in it. Okay. Reason for the water is we can actually collect gas through water, and it's not going to escape as long as we do it correctly. You're then going to take a graduated cylinder and you're going to lay it down sideways into this bucket of water. And what that's going to do is it's going to fill up the graduated cylinder with water, at which point in time, once it is completely filled, and it needs to be completely filled with no gas bubbles in any way, shape, or form, you are going to invert said graduated cylinder into your bucket. And again, it's going to be filled with water all the way up to this top lineup, all the way up here. Okay, and at that point in time, we're now able to collect our gas and measure the water displacement to measure the gas volume that's actually collected. So from here, what we're going to do, we're going to take our lighter, and keep in mind, lighters are not allowed on school premise. So you will need to be very cognizant about using it and extraordinarily respectful about using it. You will not light it in any way, shape, or form. If Mr. Christie sees fire, or sees you playing with the lighter, it will be taken up and will result in an automatic write-up for everybody in your group. So please be cognizant of that. Mr. Herring's been very gracious and allows us to use the lighters for this particular lab. So we are going to be respectful about that. Okay, from there, what you're going to do is you're going to stick the lighter under the water, and you're going to lift up the graduated cylinder just a little bit so that you can get your hand and the lighter up underneath it. Make sure that the water level and the graduated cylinder, or make sure that at least the graduated cylinder does not go outside of the water level, because if it does, the water that you just filled the graduated cylinder with will come out. So once you put the lighter underneath here, you're going to click it, and what's going to happen is gas bubbles are going to form, and those gas bubbles are going to move all the way up into our graduated cylinder, and it's going to displace the water in the graduated cylinder. What that's going to allow us to do is that's going to be able to allow us to measure the amount of gas in the graduated cylinder via volume. So this gives us the volume of the gas. Now keep in mind, you are collecting two different gases and technicalities here. You are collecting the gas from the lighter, but you are also collecting water. So something we really haven't talked a lot about, but we will be talking in the next chapter, is something called vapor pressure. And I believe I have mentioned it to you guys before, but if not, it's a pretty simple concept. Basically what that is any liquid, and even solids technically, will have, in a closed system specifically, will have a certain amount of gas that forms over them. Now, the amount of gas that forms over them is going to be related to their intermolecular forces. So the stronger the intermolecular forces, the less gas that's going to be able to be created. The weaker the intermolecular force, the more gas that's going to be created. And this is also proportional to temperature. So the higher the temperature, a lot of times the higher the vapor pressure, and the lower the temperature, the lower the vapor pressure. So this is something really important to keep in mind. We are collecting this over water, which means there is going to be water gas present in our actual gas from our lighter. So we will have to take that into consideration in just a minute. So keep in mind, you're not just collecting one gas. The volume of gas that you created in here is actually for 2 different gases. But keep in mind, even if you collected 5 liters, it would be 5 liters of the lighter fluid, which we'll just call LF, and it would also be 5 liters of the water vapor, because both gases are taking up the full area in which you are collecting gas. So that really doesn't affect our volume measurement, but it does affect our pressure measurement. So let's talk about pressure. This is what we call an elastic system. What that basically means is the pressure inside of here for the gas will match the pressure outside here in our atmosphere. The idea behind this is the gas is pushing down on the liquid, and the gas is pushing down on the liquid out here as well. So these two are balanced and equal to each other. It's kind of like a balloon. If I blow up a balloon, the balloon's going to fill with air to a certain volume. Well, the certain volume that it fills up to is due to the fact that the pressure inside the balloon is going to be equal to the pressure outside of the balloon. So anytime we have an elastic situation, we can assume the pressure inside is equal to the pressure outside. And again, this is elastic because our water levels can change in both areas based off the pressure. So if I was to push down here and increase pressure outside, it would shoot the water up in here, therefore increasing the pressure in here as well. If I was to create more gas, it would push the water level down, again balancing our 2 pressures. So either way. Now, the pressure that's important here is equal to our atmospheric pressure, which will be dependent on today's weather, more or less, because remember, as storms or as cold fronts or high fronts or anything like that move in, it will affect our atmospheric pressure. So you'll need to get this from the Weather Channel, or Mr. Christie will provide it for you on the board. Either way, you will have to get your atmospheric pressure. Now, what's important to remember is that atmospheric pressure is our total pressure. From there, we have to recognize that our pressure is consistent of 2 gases. It's consisted of the vapor pressure we just talked about, which will be a fairly small percentage of our total pressure due to the fact that water does have strong intermolecular forces. Therefore, a lot of it will not be collected, but you will have enough up there that it will affect our math, as well as the pressure of our lighter fluid. And again, we'll call this LF. So you have to take this into consideration. The nice thing is this value is a constant value based off of temperature. So you'll be given a list of different temperatures and the pressures associated to the vapor pressure of water at those temperatures. Okay, so that will make your life a little bit easier. And then from there, you'll calculate your lighter fluid pressure. So we've already got volume taken care of. It's here. Where do we get temperature from? Temperature from here, ideally what would happen is we'd leave the water out all period long, or actually all morning long, so that it ends up being the same temperature as room temperature, but chances are that's not going to happen. And since you are collecting the gas through the water, because you're putting it in the water and collecting it in through the graduated cylinder through the water, you want to measure the temperature of the water, because chances are the gas will be more closely related to that temperature versus the atmospheric temperature. So that's where we're going to get our temperature, and that's also the temperature we're going to use to find our vapor pressure of water. Now, where do we get mass? The mass is going to be calculated from getting the initial mass of the lighter and the final mass of the lighter. And the difference between these two, it should be final minus initial, will be the total amount of gas or lighter fluid that we put into the system. Now, the hardest part of this is you are getting the lighter wet. Okay, so you have to remember that final mass will include water weight if you are not careful. You are going to have to do your best to get that thing dried as much as physically possible and to make sure that you get the water out of all the nooks and crannies. Okay, once you have that, you'll be able to do your math and get your mass of the experiment from there. Okay, so that's how we go through and find all these pieces. Once we have all those pieces of information, we can go up here and plug them into either one of our equations. So if you're using the molar mass times pressure, density, RT, etc., molar mass is what we'd be calculating. Pressure would be our pressure of our lighter fluid, which we just calculated. Density would be mass over volume, which you would have just calculated your mass from doing this down here, way over here. Okay, and you would have gotten your volume from your graduated cylinder. Of course, R's are constant. Be careful here. Chances are you're going to get pressure in inches mercury because that's how we get it in America. You will need to convert that to millimeters mercury, and either from there you can convert that for millimeters mercury into ATMs, or you can just use millimeter mercury, but make sure your R constant matches whichever value you're using. You cannot use inches mercury for any of our equations because none of our R values have that present. And of course, temperature you'll need to convert into Kelvin, which will be your water temperature from there. Same thing up here. If you're using PV equals nRT, you'll plug in your pressure, which is pressure of the lighter fluid, volume, temperature of the water. Make sure your R matches, and you'll calculate moles once you have moles, recognizing that, here we go, molar mass and moles are related by this equation, where moles is equal to the mass divided by the molar mass, or you could have molar mass is equal to your mass divided by 1 mole. So you could divide your mass by moles and get that ratio of mass per 1 mole and find your molar mass. So either one of these equations will work just fine. But that's kind of the nitty-gritty of how to work through this lab and collect the correct data. So be cognizant and careful as you're going through. And hopefully this helped. Thanks, guys.